Right. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing our last notes of Unit 2, which is Unit 2, Learning Target 11. So what we're going to talk about today is how to decide when to use what method. I get a lot of questions of, well, how do I know I need to use that one? How do I need to know I need to use that one? The fact of the matter is you can really use both methods whenever you want. Sometimes, though, some methods are easier than others. So when to use substitution? It's good if it's solved for a variable or there's a positive coefficient of 1 because that makes it easy to solve for another variable. When to use elimination? If it's in standard form especially, and if there's the same letter with the same coefficient and maybe it already has an opposite sign or all you have to do is make an opposite sign. So what we're going to kind of do is we're going to go through about 10 practice problems, and we're just going to kind of decide which method should I use, okay? Now, most of you are comfortable with elimination, so if you see a problem that I use substitution and you want to use elimination, I say more power to you. So the first thing I notice about number 1 is that it is in standard form, which to me says, all right, you know what? I'm just going to use some elimination. So what I'm going to do is I'm going to take, so I notice that my y's have opposite signs, but what they don't have is the same number. So what I'm going to do is I'm going to take the top equation and I'm going to multiply it by 5, and then I'm going to take the bottom equation and I'm going to multiply it by 3, okay? So then when I do that, I end up getting 25x plus 15y is equal to 16 times 5, which is 80. The second equation, 9x minus 15y is equal to negative 4 times 3, which is negative 12. Okay, so now I can go ahead and add down the columns. Well, 25x plus 9x is actually going to give me 34x. The 15y's are going to cancel out because they're opposites. And then 80 minus 12 is going to give me 68. So I'm going to divide both sides by 34, and I end up getting that x is equal to 2. So now that I know that x is equal to 2, I can plug it in for x here or here. Here. It doesn't matter which one. So let's just plug it into the top one. So I'm going to have 5. I'm going to take the x out and put 2 in instead. Plus 3y is equal to 16. So then 5 times 2 is 10. Plus 3y is equal to 16. Subtract 10 from both sides, and I get that 3y is equal to 6. Divide both sides by 3, and I get that y is equal to 2. So then what we're going to do is we are going to have a point 2, 2 as our final answer for number 1. So now, taking a look at number 2. Number 2, first of all, I was thinking I want to use elimination simply because I have same number opposite sign. Okay, and I have standard form. So not using elimination on this one would be making my life a lot more difficult. If you chose to use substitution, then you'd end up with a fraction and decimals, and no one likes that. So I can actually already add down the columns because those two will cancel out. So 3x plus 2x is 5x, and 13 plus 7 is 20. So then I can go ahead and divide both sides by 5, and here I get that x is equal to 4, or y as it looks like on here. Okay, so now I know that I can take this 4, and I can plug it in for x there or there. So I'm going to plug it into the top equation, just because. So I have 3 times 4 minus 5y is equal to 7. So then 3 times 4 is 12, minus 5y is equal to 7. Subtract 12 from both sides, and I get a negative 5y is equal to a negative 5. So then I'm going to divide both sides by a negative 5, and when I divide two negatives, it's going to become positive, and 5 divided by 5 is 1. A lot of students like to tell me that that's 0, but it's not. A number divided by itself is always 1. All right, let's take a look now at number 3. So for number 3, the first thing I'm going to do is I'm going to rewrite this equation so it's actually in standard form, so I have my y second. So I'm just going to start by doing that and then just see what that gets me. Okay, so what I noticed when I flip those around, that I have same number opposite signs on my y's, which means I can go ahead and add down the columns. So 3x plus 5x is 8x. Then the y's are going to cancel. 24 plus 8, that's going to give me 32. Divide both sides by 8, and I get that x is equal to 4. Oops, why does it always write it as a y? That's so annoying. So now I can plug it in for y here or sorry, for x, not y, for x here or here. So I'm going to plug it into the first one. So I'm going to have y plus, remember you could plug it into the second one if you want to, take the x out and put 4 in instead, and that's equal to 24. Well, that's going to be y plus 12 is equal to 24. Subtract 12 from both sides, and I end up getting that y is equal to 12. So my answer here then is 412. Okay, so now let's go ahead and let's take a look at number 4. So what I noticed about number 4 is, again, it's already in standard form. And we're going to see that a lot because when we write word problems, a lot of times when we write them, it ends up in standard form. So let's go ahead and take a look at number 4. I noticed that my y's have opposite signs. So now I just need to multiply to make them the same number. So I'm going to go ahead and add the bottom, or multiply the bottom equation by 3. So I get 5x plus 3y is equal to 3. And then the bottom equation is going to become 6x minus 3y is equal to 3 times 10, which is 30. So then I can cancel out my 3y's because now they have the same number and the opposite sign. Well, 5x plus 6x is going to give me 11x, and then 30 plus 3 is going to give me 33. So I'm going to divide both sides by 11, and then I end up getting that x is equal to 3. So that's my x. So now I can take that x and I can plug it in for x there or there. So let's just go ahead and let's plug it into the bottom equation just for something different. So I have 2 times 3 minus y is equal to 10. So then I have 6 minus y is equal to 10. Subtract 6 from both sides, and I get that negative y is equal to 4. So I don't want to know what negative y is. I want to know what y actually equals. So then I need to divide both sides by a negative 1, and I get that y is equal to a negative 4. So then I get 3 negative 4. And that's my final answer for number 4. So let's go ahead and let's take a look at number 5. So again, I notice that it's in standard form, and I notice that I have same number with opposite signs. Okay, so I'm going to try doing this using elimination. So what I'm going to do is, since it's same number, opposite signs, I'm just going to multiply this top one by 4 because that's the bottom coefficient, and this bottom one by 3 because that's the top coefficient. So when you multiply in the 4, you're going to get 16x plus 12y is equal to 19 times 4, which is 76. 3 times 3x is 9x. Negative 4 times 3 is going to be a negative 12y, and that's going to be equal to 3 times 8, which is 24. So here, my y's are going to cancel out. 16x plus 9x is 25x. And then 76 plus 24 is going to be 100. So I'm going to go ahead and divide both sides by 25, and I get that x is equal to 4. So now I know my x is equal to 4, so I can substitute that in for x there or there. So let's go ahead and do the top one. So I'm going to have 4 times 4 plus 3y is equal to 19. So I have 16 plus 3y is equal to 19. So I'm going to subtract 16 from both sides, and I get 3y is equal to 3. Divide both sides by 3, and I get that y is equal to 1. So then I have the coordinate point 4, 1 as my answer for number 5, which I think was an answer to one of our other problems too. Cool, I think, maybe not. Okay, so let's go ahead and let's take a look at number 6. So number 6, shock of all shock, is actually something that I want to use substitution on. And the reason being is it's already solved for y here. So it makes it really easy to just plug it in for y down there. You could work to bring the x over to the other side and use elimination, but I'm going to do substitution on this one. So we're going to get 3x minus 2. Now instead of writing the y, I want to put that 4x plus 11 in instead, and that's going to be equal to a negative 7. So 3x, negative 2 times 4x is negative 8x. Negative 2 times 11 is negative 22, and that's equal to negative 7. So negative 3x minus 8x is negative 5x minus 22 is equal to negative 7. Add 22 to both sides, and I end up getting that negative 5x is equal to a positive 15. Divide both sides by a -5, and I get that x is equal to a -3. So now I know that that's what x is equal to. So where I see x right there, that's what I'm going to plug in. So then I get that y is equal to 4, and now instead of writing the x, I'm plugging in that -3 plus 11. Okay? So then I get -12 plus 11 is equal to a -1. So then my final answer is -3, -1. Okay? Moving forward, let's take a look at number 7. So I see on number 7 that I have things in standard form and that I have the same number opposite signs. So to me, what I would want to do here is I would want to use elimination, but I need to make them opposite. So what I'm going to do is I'm going to take maybe just this bottom one and multiply it by a -1. So that's going to become 5x minus 2y is equal to 12. And then -3x plus 2y is equal to a positive 2 when I multiply that -1 all the way through, excuse me. So 5x minus 3x is going to give me 2x. And my 2y's are going to cancel out, and 12 plus 2 is going to give me 14. Then to solve for x, I need to divide both sides by 2, and I get that x is equal to 7. So now I know that x is equal to 7, so I can go ahead and substitute that in. So I have 5, and I'm going to take the x out and put 7 in instead. Minus 2y is equal to 12. So 5 times 7 is 35, minus 2y is equal to 12. Subtract 35 from both sides, and I get that a -2y is equal to a -23. Divide both sides by a -2, and I get that y is equal to 11.5. So we're going to write that out as a solution. First our x, and then our y. So that's our final answer for number 7. So taking a look at number 8, I immediately notice that it is in standard form. Okay, so that to me usually means we're going to use elimination. And even luckier, I notice that, wow, this is taking a while to erase. I notice that I have 8 and -8. So actually, this one right here is all set to use elimination. We already have our opposite signs even. So 9x plus 4x is going to give me 13x, and thankfully, those are just going to cancel out for me. 42 minus 16 is 26. So then I'm going to divide both sides by 13, and I get that x is equal to 2. So now I know that x is equal to 2. So where I see x there or there, I'm going to substitute that in. So let's go ahead and put it into the top one. So I'm going to do 9 times 2 minus 8y is equal to 42. So then I'm going to get 18 minus 8y is equal to 42. So then we're going to subtract 18 from both sides, and then we're going to do -8y is equal to 42 minus 18, which is 24. Divide both sides by a -8, and I get that y is equal to a -3. So then I have 2, -3 as my solution. Okay. Next, let's go ahead and let's take a look at number 9. So what I noticed about number 9 is that it's already solved for 3x. So I'm going to use substitution. So y is equal to 3x. So where I see y in that second equation, I'm going to put in 3x. So the 3x is going to stay in the second equation. So is the 4. But instead of writing y, I'm going to write 3x. Okay? So then I get 3x plus 4 times 3, which is 12, is equal to 30. So then I get that 15x, that is the worst 5 I've ever drawn, is equal to 30. Divide both sides by 15, and I get that x is equal to 2. Okay? So we know that y is equal to 3 times x. So really, y is just equal to 3 times 2, which means that y is equal to 6. So then we have the point 2, 6 as our solution for number 9. Okay, so I want to do one more practice problem with substitution. So when you take a look at number 10, you actually can do substitution on this one. It's really easy to solve this equation for this first equation here. It's really easy to solve it for y. So you can go ahead and add y to both sides. And you get that x is equal to y plus 2. So we need to substitute that in for x right there. So then we're going to have 5 times y plus 2 plus 3y is equal to 18. So 5y plus 10 plus 3y is equal to 18. So 5y plus 3y is going to give us 8y plus 10 is equal to 18. So then I need to subtract 10 from both sides, and I get 8y is equal to 8. Divide both sides by 8, and I get that y is equal to 1. So now I know that y is equal to 1. So I can take the fact that y is equal to 1 and plug it in for y up there. So x is equal to 1 plus 2, which is going to give me 3. So then my solution is 3, 1. So that's my final answer for number 10, and that concludes your note video and all of them for this week. Thanks for listening. Bye.